Okay, so we're going to talk about circles. By the way, circles are not functions. So they're not functions, but it's a relation. Okay, say you go out in the dirt and you stick a stick in the ground, and then you tie a string around that, and then pull the string taut, and then you take another pointy stick, like this, and then you move that pointy stick around, keeping that string taut all the way around, then you're going to get a circle, okay? I made it dotted, but I'm not great at drawing circles. Just do our best. That's the definition of a circle. It's the radius, which we mark as r, that's constant, okay? So now we're going to go to this little circle we have here. We're going to say it's based on where your center is. Now we're going to make the center of our circle h, comma, k. That stays put, right? Like you didn't ever move the stick where you put in the ground at first, right? That stays fixed. And then these points along, my dotted points here, that's where all the distance was being the same. It was always r, right? So the distance from any point on the circle to the center was the same radius. Okay, so pick a point somewhere on the circle and call it x, comma, y. So we're in a Cartesian coordinate system. We're going to say, the center is at some point. We don't know what that point is, but hk. And then x, y, well, that's going to be, there's lots of combinations of x and y because there's an infinite number of points on that circle. Okay, now to find the distance, r, we can use the distance formula, right? So the distance is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2, oh shoot, that's supposed to be a minus y sub 1 squared, and that would equal the distance. Okay, we know the distance. The distance is the radius. Okay, and we know we're going to call this the first point and this the second point. And we're doing this for any x and y, any point on the circle. So it's going to be x minus h squared plus y minus k squared. And you could leave that formula like that, but usually for the standard form of the equation of a circle, which is what we're coming up with, they're going to square both sides. So they're going to square this and they're going to square this. And so here comes the standard form of a circle. It's going to be, and I'm going to switch it the other way, but it's going to be x minus h squared plus y minus k squared equals r squared. So it kind of looks like the Pythagorean theorem. And this is for a center of hk and radius r. R radius. The radius is r. Okay? So that's what you have to make a circle. You have to have the center, and you have to have the radius, the fixed piece of string, the length of string. Okay, so it says write the standard form of the equation of a circle with center 0, 0, and radius 2. Okay, so here comes the standard form for a circle. We just wrote that. You don't have to write it again, but I'm going to. This is my h, and this is my k, because that's the center. So x minus 0 squared plus y minus k 0 squared equals, and the radius was 2 squared. So we just clean this up a little bit. It's going to be x squared plus y squared equals 4. Okay, that's then the standard form of this equation that has a radius of 2 and is centered at the origin. Now, if I were to graph this, and I didn't provide graph paper for you, I'm going to show you how we graph a circle. This is kind of the mathematician's way of graphing a circle. If you really wanted a circle, you go get a compass and you can make nice circles. But all right, the radius we know was 2, right? The center was 0, 0. So here's the center, which, by the way, the center is not a point on the circle. Okay, it's important to our circle, but it's not a point on the circle. And then the radius was 2. So just go 2 in each direction. So here's a point, here's a point, here's a point, here's a point. And then just try to draw the best little circle you can. I'm out of practice. Okay, not too bad. The smaller the circle, usually the easier they are to make. Try not to make it look like a football. That's what I ask. But you just try to draw your best. Okay? You could find more points on that circle. There's an infinite number of points. But for our purposes, we just want to get, kind of those points there, those ones in the axes, the vertical and horizontal axes. And then we can just do our best to draw a circle. All right.